So the next part is a multi-pulse sequence. So now we need to have multi-pulses, and what we need is A pulse at roughly 20%, B pulse roughly 40% width, and then we have a delay of 100 microsecond. Mode is internal again, repetition is 100%, 10%, 100 millisecond, 10% of that is roughly 10 milliseconds of delay between the repetitions. Number of B pulses, now we have 2 B pulses, sync still on A, and A and B are both on, and the scope has some sort of sweeping milliseconds, 0.1 millisecond per centimeter or per block division, and we have the same setup. So let's get started with the A pulse width roughly 20%. Okay, so that's close enough to 20%. We're not exact. 40% B pulse, and the delay is 0.1 millisecond. So that's 0.1 times 10 to 0, 0.1 millisecond. That's 100 microsecond, and that was the same as before the last test. So the internal 100 millisecond, 10%. Now we want to increase B pulse to 2. So I want you to watch this thing as it happens. So I'll first reset the horizontal of the scope, and then I'll zoom in somewhat. Okay, so now I want to increase B pulse to 2 pulses. Right here, this is the number of B pulses. I want to increase that to 2. So you should see, well, there's a second B pulse coming out. And the delay between the B pulse, between B pulses and A and B pulse seem to be related. If you don't trust me here, let me demonstrate that. Let's move A pulse here to, okay, so to the left cursor. Okay, so okay, A pulse is on the left cursor, and the first B pulse on the right cursor. So we're roughly 100 microseconds apart. 100 microseconds apart, delta t. And if I move again with that 100 microsecond already in tow, so what is this? Okay, it's 300 microsecond. So that means the delay is applied between A and B pulses, and then twice of that delay is applied between subsequent B pulses. I can add more B pulses if I want. Let's just go ahead and add a couple more. See that? All of the delays are twice the AB pulse delays apart between the B pulses. Okay, so let's see what else we have in here. Let me do this. Let me move that over here and do a recording. So this is showing that 100 microseconds. Okay, so let's save that. Okay, we just finished saving. Now we can move the cursor to the B pulse. Actually, I want to just do this. Move both cursors. So now the cursors are showing between the 2 B pulses. And as you can see, there's 200 microseconds delay, exactly twice as the AB pulse difference. So we're saving it. Let's pause. Okay, so we just saw how to add B pulses, numerous B pulses, and over here, so change the number of B pulses from 3 to 10, and note the width of the spacing between the pulses. So we just noted the spacing between B pulses is twice the spacing between A and B, and that spacing is from the rising edge to the other peak's rising edge. So change the mode switch to manual and press the manual start, and change the delay to the 2 millisecond, and then to change that, and notice that the time scale, the pulse appears spikes. It is difficult to observe, and we already saw that when the B pulse is charged, is changed over its entire range, that we have already seen that happening. So I think we have basically finished up all the getting started with the pulse generator, which is the middle section of this framework. Thanks.